After generating our message, now we will modulate it by using QPSK modulation. For those who do not know the QPSK modulation, they can refer to the manual. We have the figure there. Let me show it to you. So this is the QPSK modulation, and this is the arrangement of symbols. That means in the incoming messages and incoming bits of your messages, based on what it comes, you can map them like 2 bits per symbol. So this is what we call symbols. So each symbols represent 2 bits. For example, if you have at the incoming sequence you have 0 0, that means we're going to map that 0 0 into this position, which is determined by its phase here, the angle. That's why we call this phase shift keying, because the information are being carried on the phases. So these are the phases that we will be using to carry our information, and each phase represents 2 bits. And there are different ways of implementing this QPSK modulation. As you can see in the figure 1, we have this format, and the figure 2 we have this format, and so there are many other formats, and also you can even develop your own format. So this part of the code here implements just what I showed to you, and there are also different ways of implementing this. So this is one way. Apart from this, as you can see here, so these are the symbols which represent the phases that we are mapping our bits into, and then the rest of it is just doing the mapping of the incoming bits to these phases. This we are doing it by our own, but also you can use the MATLAB toolbox to implement the same thing. So here I'm showing both our own thing and also this from the MATLAB, so you can choose whichever you want, or you can also come up with your own way of mapping these bits into these phases, to these symbols. In the MATLAB command, we can use the communication toolbox to generate an object. We call it my modulator object. So we have to specify a number of parameters. So like you have to specify the modulation order, because this is generic for any PSK modulation. So we have to specify the modulation order, which we have done that before in our simulation parameters. If you can remember, it's here. So we just take this variable here, and also you have to specify the phase offset. As I said, this is generic, so if you don't specify the phase, it will give you, by default it will give you this one. But in this particular lab we want to implement this one. So from here to here we have to shift these constellations by pi/4. So that's why here we are specifying the phase offset to be pi/4, and also as we have seen, our message we generated it in terms of bits. So we say that bit input, we want our object to take the input message in terms of bits, because it can also take it in terms of integers. So these are the important parameters that we need to specify for now. So I will plot the results of both of these to see how they operate. I will start with this one, and then we will come and see this one. To do that, I will just plot the constellation diagram similar to the one we have seen on the manual. Then to plot the constellation diagram, we use the scatter plot. This is also a MATLAB command. So as you can see, this one is 0 commented out, so we will not run this one, we'll only run the first part. So I will stop here. Let me run it and see what we are getting by using our own way of implementing it. Oh, I stopped it at the wrong place. Let me stop it here. Okay. Now I'll run it again. Okay, now you see, so our code worked properly, and this is what we have here. We have the symbols here, and here. as we expected. So let's see the MATLAB command direct. What does it do? I'm gonna close this. Now I'm gonna put this 0. I'm gonna put this off, and I'll put this on. We'll repeat the same thing. So again, the same results we're getting. So this is our symbols. All bits are mapped to their respective phases where they're supposed to be. And apart from this, I can show you what will happen when we have 0 here. So I'll just multiply that thing with 0. Or I can just remove it. So now we have 0 phase. You will see so you can see now our symbols are on the axis, like on the real and imaginary axis. They are not here. So here it's like phases are 90, 180, 0, and 270, similar to the first figure on our menu, on our lab menu. So that's how we do modulation. As I said, you can find your own way of mapping these bits, the message bits, into the symbols, or you can use MATLAB toolbox to do that. So after this, we move to the next step, which is pulse shaping of the message symbol that we have just produced.